Hey guys, welcome to week 9, the last week of remote learning. Me and Miss May, we are super amped and proud of you guys for sticking through this with us. Because of that, we're only giving you 2 things this last week. It's going to be 12.7 homework. There will be notes that you will be using for that. And then the last one will be a Chapter 11 mini skills review worksheet. It's pretty quick. Just the last 2. So Miss May, the 12.7 is due when?
Wednesday.
And what else is due Wednesday?
All missing work.
Cool. And then on Thursday by 4 p.m. What's due then, Miss May?
The Chapter 11 skills review.
Nice. Okay,
and
so that's it.
No late assignments will be accepted after Thursday at 4.
Right,
so
because we're finishing grades.
On time.
We're finishing grades on Friday, so make sure you get it done. All right, good luck, guys. See ya.
12.7 is probability. Probability comes up a lot in real life. So how likely an event is to occur is called the probability of an event. That's what that notation means. Theoretical probability is based on what you know. Experimental probability is based on data collected from repeated trials. So the probability of n is the desired outcome divided by the total outcomes. Or a similar idea, number of times desired event occurs over the total number of trials. And again, this is the notation you often see. Probability of something. All right, here's our first example. In a taste test, there's 50 participants are randomly given a beverage to sample. There's 20 samples in drink A, 10 in drink B, 10 in drink C, 10 in drink D. So for drink A, there's 20 samples. For drink B, there's 10. For drink C, there's 10. And for drink D, there is 10 samples. And the total was 50 participants. These also add up to 50 here. So the question is, what is the probability of a participant not getting drink A? So you need to do the number of desired outcomes. So how many are not A? Well, here's the number of A, so then the rest, 10 plus 10 plus 10, there's 30 outcomes that are not A. And then you do it out of the total trials, or the total of outcomes, which was 50. And then what we're going to do for probability is just write it as a reduced fraction. These both can divide by 10, and then I just get a probability of 3 over 5. You often see probabilities as percents as well, but just leave it as a fraction for the homework. So that's how you're going to do probability. Another thing that comes up in probability is odds. So what are the odds in favor of, it's important, odds in favor of the spinner landing on a number greater than or equal to 6. So here's our spinner over here. We want to figure out how many are greater than or equal to 6. On the screen? Still on the screen. Well, that would only be 6, 7, and 8 because it's equal to 6, 7, and 8. That's 3 of them are in favor of getting a number greater than equal. So then the odds here would be there's 3 that are in favor, and then for odds, you put on the other side of the colon how many are not in favor. So not greater than or equal to 6 would be the rest. 1, 2, 3, 4, 5. 5 numbers are not. So the odds in favor are 3 to 5. That's how you write it, the odds. You see that often in statistics with sports. I just want to talk about probability. If it said what is the probability of the spinner being greater than or equal to 6, this one is a little different. You do the number of outcomes that are true. 3 are greater than or equal to out of the total. There's a total of 8, and that's a reduced fraction. So make sure you pay attention to the wording in the homework. Odds and probability are very different. So try out the odds and probabilities for these 2 practice problems here. All right, what are the odds of the spinner landing on a number less than or equal to 4? So less than or equal to 4, just less than 4 would be 1, 2, and 3. So there would be 3 of them that are less than 4. So for odds, it would be 3 that are less than 4, just less than, in comparison to the 5 other ones that are not. So the odds would be 3 to 5 for a number less than 4. The probability of a number greater than 4, I just did it wrong again, less than 4 would be 3 out of my total of 8. So you end up getting the same odds and probability as the last one. What are the odds of the spinner landing on an even number? So for odds, you would figure out how many are even. 2, 4, 6, 8. 4 are even, and 1, 3, 5, 7 are not even. So the odds of getting an even number would be 4 to 4. Probability of an even number would be 4 out of my total of 8, and then you write it as a reduced fraction. Boom. So just pay attention on the homework if it says odds versus probability. Our key word for the week is last notes. What? These are the last notes of the year.
Woo.
So exciting. So make sure you write that at the top of your homework for this assignment. Next, we're going to talk about experimental probability. For experimental probability, it's based on data collected from repeated trials. So probability event is it's the same as before, the number of desired events over the number of times this experiment is done, or the total times done. All right, here's our first example. After receiving complaints, a skateboard manufacturer inspects 1,000 skateboards at random. The manufacturer finds no defects in 992. What is the probability that a skateboard selected at random has no defects? So, probability of no defects is going to be the number of skateboards with no defects, 992, divided by the total number tested, which is right here, 1,000. For this one, for experimental probability, you're going to write it as a decimal. So you get your handy dandy calculator out. We do 992 divided by 1,000. We get 0.992, and then you guys got it from here. To write it as a percent, you move the decimal left twice. So I get 999.2%. So 99.2% would not have any defects. All right, here's the last example here. You ask 500 randomly selected households in your town if they have a dog. Of the 500 households, 197 respond that they do have a dog. If your town has this many households, how many households are likely to have a dog? So, probability, you own a dog. The number of respondents that own a dog, well, 197 responded that they do have a dog. 197 divided by the total number of households surveyed. 500. So then we write this as a decimal. 197 divided by 500. We get 0.394, which as a percent would be 39.4%. But that's not what the question asked. It says if your town has this many households, how many, using this probability, would likely have a dog? So for that one, you take your probability. I'm going to rewrite it as a decimal though, because we want to change our percents to a decimal, times the total number of households. For our new situation, it would be 24,800. So you take that answer you just got, 0.394, our probability, and you multiply it by 24,800. So if this many households were surveyed, then you would have 97,712 households with dogs. All right, good luck on the homework. Remember, everything is due by Wednesday for all missing work, and Thursday your chapter 11 skills is due, and then you're done.